Mitigating lightning attraction hazards on steel plates is crucial for facilities that use them, especially those with heavy equipment. Proper grounding of the steel plates is essential to safely discharge lightning strikes. Install ground rods around the perimeter of the plates and connect them using heavy-duty copper wire. The goal is to provide a low-resistance path for the lightning current to flow to ground, minimizing the risk of damage or injury. Secondly, install surge protectors at all electrical panels and outlets near the steel plates. These devices will divert excess voltage spikes caused by lightning strikes, protecting sensitive equipment from damage. Surge protectors are designed to clamp the voltage to a safe level, preventing it from reaching sensitive electronics. Thirdly, consider installing lightning arresters on top of nearby structures or tall equipment. These devices intercept lightning strikes and redirect them to ground safely, providing an additional layer of protection. Lightning arresters typically consist of a pointed rod connected to a grounding system. Fourthly, if possible, insulate the steel plates from the concrete pad using non-conductive rubber or plastic material. This will reduce the risk of grounding faults and potential sparking. Insulation helps to prevent the flow of current between the steel plates and the concrete, minimizing the chance of electrical hazards. Fifthly, post warning signs around the steel plates informing personnel of the potential lightning hazard. Conduct safety training sessions to educate employees on the risks and mitigation measures. Signage and training are important for raising awareness and ensuring that everyone knows how to respond in the event of a lightning strike. Sixthly, install a lightning detection system to provide early warning of approaching thunderstorms. This will allow personnel to take precautions, such as seeking shelter indoors or in lightning-safe vehicles. Lightning detection systems can provide valuable information about the location and intensity of lightning strikes, allowing for timely warnings. Seventhly, regularly monitor the area for signs of lightning strikes or damage. Inspect the steel plates, ground rods, and any other lightning protection equipment for any issues. Regular monitoring helps to identify potential problems early on, before they can lead to serious consequences. Eighthly, perform regular maintenance on the grounding system, surge protectors, and any other lightning protection devices to ensure optimal performance. Maintenance ensures that all lightning protection systems are functioning properly and ready to protect against lightning strikes. Additional recommendations include considering the use of non-metallic materials for any structures or equipment within the immediate vicinity of the steel plates. Non-metallic materials do not conduct electricity, reducing the risk of lightning-related hazards. Provide designated lightning-safe areas for personnel to shelter during thunderstorms. These areas should be located indoors or in vehicles that are designed to provide protection from lightning strikes. Implement a lightning safety plan that outlines procedures for emergency response and evacuation. The plan should include clear instructions on what to do in the event of a lightning strike, as well as evacuation routes and assembly points. Grounding systems are a critical component of lightning protection. The purpose of a grounding system is to provide a low-resistance path for lightning current to flow to ground, safely dissipating the energy. A properly designed grounding system will minimize the risk of damage to equipment and injury to personnel. The grounding system should consist of ground rods, ground wires, and bonding connections. Ground rods should be installed around the perimeter of the steel plates and connected to the plates using heavy-duty copper wire. The ground wire should be sized according to the National Electrical Code, or NEC, requirements. Bonding connections should be made to all metal objects in the vicinity of the steel plates, such as pipes, fences, and equipment. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning strikes or other events. Surge protection devices work by diverting the excess voltage to ground, preventing it from reaching sensitive electronics. Surge protection devices should be installed at all electrical panels and outlets near the steel plates. The surge protection devices should be sized according to the NEC requirements. Lightning arresters are designed to intercept lightning strikes and redirect them to ground safely. Lightning arresters are typically installed on top of structures or tall equipment. The lightning arrestor should be connected to a grounding system. Insulation can be used to reduce the risk of grounding faults and potential sparking. Insulation involves separating the steel plates from the concrete pad using a non-conductive material, such as rubber or plastic. Signage and training are essential for raising awareness of lightning hazards and ensuring that personnel know how to respond in the event of a lightning strike. Warning signs should be posted around the steel plates, informing personnel of the potential hazard. Safety training sessions should be conducted to educate employees on the risks and mitigation measures. Lightning detection systems can provide early warning of approaching thunderstorms, allowing personnel to take precautions. Lightning detection systems use sensors to detect the electromagnetic pulses generated by lightning strikes. The system then analyzes the data to determine the location and intensity of the strikes. Lightning monitoring involves regularly inspecting the area for signs of lightning strikes or damage. This includes checking the steel plates, ground rods, and other lightning protection equipment for any issues. Regular maintenance is essential for ensuring that lightning protection systems are functioning properly. This includes inspecting and testing the grounding system, surge protection devices, and lightning arresters. Maintenance should be performed on a regular basis according to the manufacturer's recommendations. The NEC provides specific requirements for lightning protection systems. These requirements are designed to ensure that lightning protection systems are installed and maintained safely and effectively. It is important to consult the NEC when designing and installing a lightning protection system. The NEC Section 250 covers grounding and bonding requirements for electrical systems. This section provides detailed information on how to properly ground and bond electrical equipment, including steel plates. The NEC Section 280 covers surge protection devices. This section provides requirements for the selection, installation, and maintenance of surge protection devices. The NEC Section 780 covers lightning protection systems. This section provides requirements for the design, installation, and maintenance of lightning protection systems. In addition to the NEC, there are other standards and guidelines that can be used to design and install lightning protection systems. These include the National Fire Protection Association, or NFPA, 780 standard for the installation of lightning protection systems, and the Institute of Electrical and Electronics Engineers, or IEE, 1100 recommended practice for powering and grounding electronic equipment. These standards provide detailed information on how to design and install effective lightning protection systems. Proper grounding is essential for any electrical system, especially in areas where lightning strikes are common. A properly grounded system provides a low-resistance path for fault current to flow to ground, protecting equipment and personnel from electrical shock. The NEC provides specific requirements for grounding electrical systems. These requirements are designed to ensure that electrical systems are grounded safely and effectively. The size of the grounding conductor is determined by the size of the service entrance conductors. The grounding conductor must be sized according to NEC Table 250.122. The grounding electrode system must consist of one or more grounding electrodes. Common grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode system must be installed according to NEC Section 250.52. Bonding is the process of connecting all metal objects in an electrical system together to create a low-impedance path for fault current to flow to ground. Bonding is essential for preventing electrical shock and fire hazards. The NEC provides specific requirements for bonding electrical systems. These requirements are designed to ensure that electrical systems are bonded safely and effectively. The size of the bonding conductor is determined by the size of the circuit conductors. The bonding conductor must be sized according to NEC Table 250.102. Bonding connections must be made to all metal objects in the electrical system, including metal conduits, metal enclosures, and metal equipment. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. Surge protection devices work by diverting the excess voltage to ground, preventing it from reaching sensitive electronics. Surge protection devices are rated by their surge current capacity. The surge current capacity is the amount of current that the device can safely divert to ground. Surge protection devices should be selected based on the expected surge current levels in the electrical system. Lightning arresters are designed to protect structures from lightning strikes. Lightning arresters work by intercepting the lightning strike and redirecting it to ground safely. Lightning arresters are typically installed on the highest point of a structure. The lightning arrestor must be connected to a grounding system. The grounding system must be designed to safely dissipate the lightning current to ground. Lightning detection systems can provide early warning of approaching thunderstorms. Lightning detection systems use sensors to detect the electromagnetic pulses generated by lightning strikes. The system then analyzes the data to determine the location and intensity of the strikes. Lightning detection systems can be used to trigger alarms or other warnings to alert personnel of approaching thunderstorms. A lightning safety plan outlines the procedures to be followed in the event of a thunderstorm. The lightning safety plan should include procedures for seeking shelter, avoiding lightning hazards, and providing first aid to lightning strike victims. The lightning safety plan should be reviewed and updated regularly. Here are some additional safety tips for protecting yourself from lightning. Seek shelter indoors or in a hard-top vehicle. Avoid contact with water. Stay away from metal objects. Unplug electronic devices. Wait 30 minutes after the last thunder before going outside. These measures, including proper grounding, surge protection, lightning arresters installation, signage, lightning detection, regular monitoring, and maintenance, will significantly mitigate potential lightning hazards on steel plates and ensure the safety of personnel and equipment. Remember to consult with qualified electrical professionals for customized solutions tailored to the specific needs of the facility.